This video is on concentration. We're going to talk about what it is, how to calculate it, and then we'll even get into kind of how to prepare a specific concentration solution. So liquids and gases can be easily quantified by measuring their volume. However, solutions are not as convenient because remember, solutions are made of a solute and a solvent. So we can quantify solutions through what we call concentration. And this takes into account both parts. The concentration, or C, of a solution is determined by the amount of solute and the volume of the solution. And remember, the solution contains both solute and solvent. So both parts together. So when we talk about amount, we're talking this in moles. And then solution, we're talking volume. So units are usually moles per decimeter cubed. And IB prefers to write this because they don't write like numerator denominator. So they do it side by side. Moles times decimeters to the negative third to put that decimeters cubed into the numerator. Now another way you may see this, especially like when you go to college, is instead of decimeters cubed, remember 1 decimeter cubed, that's the same as a liter. So lots of times you'll see this written as moles per liter. Another thing you might hear this referred to is that concentration, you'll hear it called molarity. And you'll see it written as a capital M. That is equal to all of these as well. That is the same thing. So molarity, capital M, is concentration. All right, so concentration is, here's our actual equation. Moles of solute over volume of solution. So simplified, this would be C for concentration is moles, so N over volume, V. All right, so you'll see this at times with square brackets. So for example, if I want to talk about, let me write this like this. If I want to talk about the concentration of an HCl solution, another way to write this would be HCl in square brackets like this. That's what that means. Concentration of HCl is square brackets. All right, so let's do an example with this problem, this equation. So a solution prepared by dissolving 7.75 grams of C6H12O6. So here we have a mass in enough water to make 450 centimeters cubed of solution. So there's our solution. We've got a volume. What's its concentration? So concentration is moles over volume of solution. So we have to convert mass to moles, and we have to convert volume to decimeters cubed. So our moles will be, if we take 7.75 grams of C6H12O6, we determine its molar mass. So if I add that up with carbon, hydrogen, oxygen in this ratio, I have 180.18 grams per mole. So that divides out my grams. So this tells me that I have 0.0430 moles of my C6H12O6. All right, so I've got my N. Now my V, my volume, and you wouldn't necessarily have to write this out, but I'm going to show you, is 450 centimeters cubed. Centimeters cubed to decimeters cubed, remember that centimeters and milliliters are the same. Decimeters cubed and liters are the same. So the conversion is the same. Centimeters cubed to decimeters cubed means I'm going to divide by 1,000. So this would be 0.450 decimeters cubed. All right, so now I can go to my equation and I can plug in my values. So concentration would equal moles, so 0.0430 moles over the volume of my whole thing, so 0.450 decimeters cubed. And when I type this in my calculator, I get, with 3 sig digs, 0.0956 moles per decimeter cubed. So your units, right? Nothing cancels. So you can write it this way, or you can write it side by side with deciliters to the negative third. All right, so chemists make solutions with specific concentrations. I do this for you in the lab all the time. So these are called standard solutions. So to prepare them, to make them, and I will show you this in class. So shown in class. All right, so you'll see it up front, but let me explain. It's, number one, the first thing is the mass of solutes accurately measured and then transferred carefully to a volumetric flask. Oops, sorry. This is a volumetric flask. So it measures things much more precisely, volumes, I should say, not things, volumes, much more precisely than like a graduated cylinder. So this one holds a volume of 100 milliliters, and that volume is right at the line that's here. And it's a very small, narrow tube, which gives you a smaller meniscus, which makes it more precise. So you add your mass to the flask. So like if it was this last one, it would have been 7.75 grams of the C6H12O6. And then you add the solvent, which is typically water. So that is steadily added, and you swirl this around in the flask to make sure the solute dissolves. Then you add more solvent all the way up to the line. And then you cap it, and this one you can see the little cap drawn in there. You cap it and you invert it, which means, right, flip it upside down. And then you always check your volume one last time, because as your solute dissolves, you might find that there's more space for more solvent, so you might have to add more solvent to get up to that line. And then you have that specific concentration. So you have to figure out your grams based on your moles. You have to do a conversion there typically, and then add water as your solvent to total your solution volume. So I'll show you this in class so you can see it up close.